Continuous delivery build pipeline. So, this is what a typical build pipeline looks like. We explored this part in the previous section. Now, let's dig more deep into each and every stage that is mentioned here. So, first, as we know, everything begins from the local development environment, where a developer or engineer makes a change on its copy of the code. They may develop new functionality using the common practices like BDD or TDD and any other extreme programming practices like pair programming and so on. One of the core goals of this stage is to make the local environment as production like as possible. And how we can do that? We can do that by running certain tests in a locally installed virtualization or container based environment. Another goal can be that if you have a larger application, then your local environment should not require all of the system components to be installed and running in order for a developer to work effectively. And this is where the design principle like loose coupling and high cohesion come into play to test the supporting practices like contract verification, doubles, and service virtualization. From the local development, when the developers working locally typically commit their proposed code and configuration changes to a remotely hosted distributed version control system like Git or Mercurial, whatever you are using, we move to the commit stage. Depending on the workflow that the team or organization has implemented, this process may require some merging of changes from other branches or the trunk or master, and potentially discussion and collaboration with the other team members working with the same code base. From the commit, we move to the continuous integration. At this stage of the pipeline, the software application to which a code or configuration change is being proposed undergoes the CI using integrated code stored within the trunk or master branch of a version control system. An artifact is built and tested in isolation. And then some form of code quality analysis should be applied to using the tools. You can use PMD, Findbug, SonarCube, and whatever. So, a successful continuous integration run results in the new artifact being stored within a centralized repository like Sonatype, Nexus, or JFrog Artifactory, and so on. So, code that successfully passes the initial unit and component test and the code quality metrics move to the right in the pipeline and is exercised within a larger integrated context. A small number of automated end-to-end tests can be used to verify the code, happy path, or user journeys within the application that are essential for the provision of business value. For example, if you're building any e-commerce application, then critical user journey can be that you're searching for a product, browsing the product, adding the product to your shopping cart, and checking out, making the payment. This is also the stage in which the system quality attributes like non-functional requirements can be validated. And why should we verify that? We verify that to check the reliability and performance, the how the system will perform when it is in load, how it is scaled, what's its capacity, and we can check the security thing as well. So that involves the scanning of the code you wrote, the dependency utilized, and the verification and scanning of all the associated infrastructure components. Then we actually move to the user acceptance test. At this stage, tester or actual users start performing exploratory testing. This manual testing should focus on the value of human cognition and not simply consist of testers following large test script. So here the common sense and the human intelligence can be applied. The repeated behavior of validating functionality from a script is ideally suited to computers and should be automated. So if your system is live, if you're building for a live system, then that is not sufficient. From here, we move to the staging. So once a proposed change has passed the acceptance test and the fundamental QA test, then the artifact can be deployed to the staging environment. So, this environment is typically close to the production. In fact, some companies do test in a clone of production or the production environment itself. So, a realistic quantity of representative data should be used here for any kind of automated or exploratory test, and integration with third party or external system should be as realistic as possible. From the staging, we move to our final destination, and that is production. So, the code that has been fully validated emerges from the pipeline and is marked as ready for the deployment into production. Some organizations automatically deploy applications that have successfully navigated the whole build pipeline and passed all the quality checks. That is called continuous deployment. But this is not an essential practice. Your company can have different set of practice for this. And once the code has been deployed to production, then it does not mean that your job is over. Then you enter into the observing and maintenance stage. So you should not forget about the observability, monitoring, logging, and alerting for both the purpose of enabling a positive feedback loop for business and technical hypotheses and for facilitating potential debugging of issues that occur within the production. So, this is how we traverse through a whole build pipeline in an environment where it has been used, and that environment is called the environment of continuous delivery. Each stage makes the way for the next, and a smooth transition between these stages tells the efficiency of your build pipeline.